we've looked at example 1, example 2, and now we are going to move on to example 3. So example 3 says, find the area of the regular polygon to the nearest tenth. To find the area of the regular polygon, we are going to have to use what we know about triangles. So I'm going to go ahead and copy down the hexagon. The center is called B. We're given the height to be 2 times the square root of 3, and it says centimeters, so this time they did give us a unit of measure. If you find the area of this triangle, it's going to help us find the area of the hexagon. The hexagon is made up of a bunch of those little triangles. They're all going to be the same because it's a regular shape. All of the base numbers are the same. So first we need to find the length of AC. The length of AC is going to be found using something that we know about special right triangles. If you were to take and calculate the angle of a regular hexagon, they will all have the same measure. So the measure of the angles in the regular hexagon comes out to be 120 degrees. So when you split that in half, because we're cutting it in half right here, we get a 60-degree angle. Which means if this is a 90, that this angle up here has to be 30. So this is what we called a 30, 60, 90 triangle. The special properties of this are that if you have the length of the base, so we called it A, you could find the hypotenuse by doubling that, and you could find the longest leg by multiplying it by the square root of 3. So since this number is being multiplied by the square root of 3, that would mean that our base is 2. So SC has a length of 2. Which means AC has a length of double that, so it has a length of 4. This is going to help us find the area of this particular triangle. So this triangle, if I shade it in here, I just copied it over here. If I were to take and reflect this triangle and then rotate, so reflect and rotate across that line, rotate across the center, I would end up with this. So I'd end up with a rectangle, right? So if I were to just take this image over here, I would have the same thing. So if I find the area of this rectangle, I've found the area of this isosceles triangle. And then I know there's 6 of those in here, so I would multiply that area by 6. So I'm just taking my base times my height. So A times the square root of 3 times A, and then I find 6 of those. So in this case, we have 2 square roots of 3 times 2. And we get that the area of this rectangle is 4 square roots of 3. From there, we take and multiply by 6 because we have 6 of those. So the area of this thing right here is 4 times the square root of 3. And then we multiply that by 6. So 4 times the square root of 3 times 6. And we get 24 square roots of 3. And that would be units squared. If you plugged it into a calculator and got an approximate answer, hopefully you got 41, so about 41.57 units squared. Now, in the example for this one, they did it slightly different. So they found the central angle of the hexagon, sorry. And then they plugged it into a formula. So that's where this comes from. So instead of doing that, I did what I knew about regular triangles and the special 30, 60, 90. You will always be able to use a special triangle property or the Pythagorean theorem when you go to do this. So don't worry about learning that formula that they showed us there. You need to complete problems 7, 8, and 9. If you have any questions, please email me because I want to help you.